It may very well be that what's going on inside of you, in your brain, in your nervous system, in your nature of observation, how memory works, how mind works, it may very well be that what is happening there is some kind of observer-matter interrelationship which is indeed making things real for you, affecting how you perceive reality. It's not changing the reality out there. You know, you're not changing big chairs and big trucks and bulldozers and rockets taking off. You're not changing those, no. But you're changing how you perceive things and maybe how you think about the things, how you feel about things, how you sense the world.
The infinite information that the brain is processing every single second tells us that there's more to the world than we're perceiving. However, every single time we're immersed in an experience with our senses, seeing, smelling, tasting, feeling, as we're immersed centrally in our reality.
We know nothing about reality, and all of our sense of so-called reality out there is filtered through our sense organs.
The brain processes 400 billion bits of information a second, but we're only aware of 2,000 of those. That means that reality is happening in the brain all the time.
You should try it. How do I know what I'm doing? I and the vase are one. Might help your work too.
I live through my eyes. Acting in reality.
Not just some nebulous, nothing, touchy-feely world of shifting whatevers.
If it's real, I want to see it.
Reality, what a concept.
What is reality, and is it ever knowable?
The easy answer to the question as to whether reality itself is illusory and it's really all fuzzy and it's all just probabilities. The easy answer to that would be yes. So, you know, if I were hurrying off to a meeting instead of being interviewed and somebody came up to me and pestered me on the street and asked that question, and I'd say, yes, that's basically right. But it's more complicated than that, because at the moment that you interact with reality, it does then come into absolutely rock-solid existence. It's only fuzzy when you're not interacting with it.
When we look at some of the modern scientific views of reality that have tried to get down to the nitty-gritty, we see that at its ultimate level, say in M theory or string theory, that reality is not solid, it's mostly empty space, and whatever solidity it has seems more to resemble a hologram picture rather than material, harsh, solid reality. It's a shimmering reality that seems to be very susceptible to the power of thought.
Very powerful mystical experiences are perceived to represent a truer form of reality, a more fundamental level of reality that makes this material world really not mean as much. And you know, some people have described it as an illusion, which I think is sometimes a little strong, but I think the point they're trying to make is that it just doesn't have the realness, the quality of realness that these states have. And the ultimate goal of the mystic then, once they've had that experience, is to kind of keep trying to get back to that experience, because that is, in their eyes, what represents the fundamental level of reality.
We have to go beyond our senses to create a new paradigm. Our senses determine everything that exists in our world. But that doesn't necessarily mean that's the end of our world. We have to embrace knowledge that's unconventional, that's in the unseen. And if we can wire it in our brain first, then what has always existed will now be seen by us. That's the paradigm shift.
You ever close your eyes when you're making love?
The eyes are like the lens, but the tape that's really seeing is the back of the brain. It's called the visual cortex. It's right back here. It's like this camera, and it's tape.
The eyes are, in some senses, a camcorder because they are taking that information and they're storing it, but you're not really able to get it to mean anything until you actually put it all together. So in some senses, it requires the editor's table to really put the whole thing together, to put the movie together of what your life and your world is actually about.
The only movie that's playing in the brain is what we have the ability to see. So is it possible our eyes, our cameras see more than what our brain has the ability to consciously project?
Well, the way our brain is wired up, we only see what we believe is possible. We match patterns that already exist within ourselves through conditioning. So a wonderful story that I believe is true is that when the Indians, the Native American Indians on the Caribbean islands, saw Columbus's ships approaching, they couldn't see them at all because it was so unlike anything they had ever seen before. They couldn't see it.
If I get out of bed in the morning, okay, and I suddenly decide to take very seriously the claim, which is surely a true claim, that I don't know for sure if my eyes are working correctly, okay? So that for all I know, even though it looks like there's a stable floor by the side of my bed, there might be a cliff or something like that, okay? If I am unable to order those possibilities in terms of probabilities that I assign to them, then I'm not going to get out of bed. Seems to me I'm paralyzed in the most literal sense of the word, okay? I'm going to have no idea how to literally take the next step. It's definitely the case that we know that my eyes might in principle be deceiving me at any moment. We've had experience of people before subject to hallucinations, and even if we didn't, we don't know how to prove as a fundamental matter that our eyes never deceive us. That's absolutely right. But when we make the decision to get out of bed in the morning, we are assigning probabilities to the various hypotheses compatible with my seeing a floor by the bed. One hypothesis is there really is a floor there, and that's why I'm seeing it. Another hypothesis is my seeing the floor is a hallucination, and there's a cliff there. By getting out of bed in the morning, you endorse one of those hypotheses as more likely than another.
When Columbus's armada landed in the Caribbean, none of the natives were able to see the ships, even though they existed on the horizon. The reason that they never saw the ships was because they had no knowledge in their brains or no experience that clipper ships existed. So the shaman starts to notice that there's ripples out in the ocean, but he sees no ship, but he starts to wonder what's causing the effect. So every day he goes out and looks and looks and looks, and after a period of time, he's able to see the ships. And once he sees the ships, he tells everybody else that ships exist out there because everybody trusted and believed in him. They saw them also.
By getting out of bed in the morning, you endorse one of those hypotheses as more likely than another. That's the way we're used to proceeding in our ordinary lives. Why are you doing that? You have all kinds of memories.
We always perceive something after reflection in the mirror of memory.
If I were to use a little bit of poetic license and say, well, what would happen if we could actually tap into the different parts of the processing steps of the visual, of how we actually develop vision? The information, of course, first strikes our eyes and strikes the retina, but that information that creates certain nerve signals that then connect back to the primary parts of the brain where the images really begin to form. In the very basic, the primary visual cortex, as it's called, what we would see is something a little bit like this, where we're basically just talking about lines, shapes, colors. There's nothing really there that we can actually identify or see or even talk about, and we're certainly not conscious of this level of activity. So this is really just the raw data upon which is coming into the world, but we can't make any sense of that. So in that regard, vision itself doesn't really occur in the eyes. It doesn't even occur necessarily in the primary visual area. But if we start to go up in terms of the processing, when we get to a secondary level of processing, we're beginning to coalesce forms and shapes. We may be somewhat conscious of this state, which is maybe associated with something called blind sight, where people don't have that highest level of processing where we see the vivid world, because consciously they say, I can't see. But if you ask them to guess at what they're looking at or to navigate through a room with objects in it, they can usually do so reasonably well, as if they can see. So what's going on, we don't know for sure, but it seems that there's a disconnection between the secondary and the final level of processing. So we have some degree of awareness, but it's still not really that clear, vivid rendition of reality. And that doesn't happen until we get up to the final stages of our processing, which is in what's called the visual association area. And when we see that, this is where we would see this very vivid picture of what the world is about. We see all the colors, we see everything as if we can perceive it to be very real. And not only do we have this very real perception of it, but again, these association areas, as they're called because they associate different pieces of information across the brain, connect this picture with memory banks. And if this is a picture of a dog, it makes, we identify it as a dog. We may have an emotional response to it. If we love dogs, then we have a warm, fuzzy feeling, and if we don't like dogs, then we may not like this kind of a picture. So it depends on what your experiences have been and how you ultimately process the information that really does create for you your visual world. So the brain itself is really what is doing all of your sensing. Conversely, the thing that I've always been fascinated about on just a very simplistic level is that when you stub your toe walking, when you bang into something, your toe hurts. But it's really hurting in your brain, and it's your brain that actually perceives the hurt, but you feel it all the way down in your toe.
It's the experiment with the upside-down glasses. This man Slater built these glasses made of prisms and lenses so that you saw things upside down. And he had a group of people wear these glasses, and he asked them to sustain wearing them. It was very uncomfortable for them because they saw people sort of walking upside down. But if they kept the glasses on, then after 2 to 3 weeks, depending upon the individual, then with the glasses on, flip, they saw everything right side up. And if they took the glasses off at that point, flip, they'd see things upside down. So what happens, the way I interpret that, is that the mindset was so strong that people walk right side up, that with the glasses on, that mindset created a force to cause the neural dendrites to grow in such a way as to create an inversion mirror in the brain. And then once that hardwired structure was built and you take the glasses off, now it has to dissolve that structure in order to see things the way you expect to see them. That's called neural learning now. We do it all the time. And I think that's the way it goes. The dilemma is people don't manifest a lot of these things because their mindset, the mindset of our world, says that we can't do those things. Those things aren't real.
You okay? I heard you scream earlier. Was it another dream? You were an Indian, watching Columbus's ship materialize out of thin air. Wow. And this medicine man kept hitting you. Cool. Hey, maybe it was a past life, or a parallel reality, or a future life.
Get here.
Or maybe that dream was trying to tell you the truth. I guess it just depends on what you think is real. Maybe you should try different anxiety pills.
My pills are fine, okay? Thank you.
I have to go get dressed. I hope you feel better, Amanda.
God, Amanda. I could be such an asshole.
People ask me, why does quantum mechanics matter, given that it's little tiny stuff and who cares? There are three possible answers. From a practical point of view, it doesn't make any difference at all. I mean, you still have to go to work and drive your car and do all the rest of it. From a second point of view, it actually infiltrates everything in the world, especially the world of electronics. When you go to the supermarket and you do the scanning at the checkout, that's a quantum mechanical effect. But I think the important part is the third one, which is essentially a philosophical issue. Why are philosophers so passionate about deconstructing the assumptions of the world? I finally got it. I got it as a result of looking at quantum mechanics and comparing it to classical mechanics. They present two very different ways of thinking about the way that the world works and about what we are. So from a classical perspective, we are machines. And in machines, there's no room for a conscious experience. It doesn't matter if a machine dies, you can kill a machine, you can throw it in a dump, it doesn't matter. If that is the way that the world is, then people will behave in that way. But there's another way of thinking about the world which is suggested, it's pointed to by quantum mechanics, which suggested that the world is not this clockwork thing, but it's more like an organism. It's a highly interconnected organismic thing of some type, which extends through space and time. In that kind of environment, what I think and the way that I behave has a much greater impact, not only on myself, but on the rest of the world, than it would if it was a classical world. So from a very basic point of view having to do with morals and ethics, what I think affects the world. That's, I mean, in a sense, that's really the key for why a worldview change is important.
Let's talk about the subatomic world, and then we'll talk about what it's telling us about reality. The first thing I want to tell you about the subatomic world is it's totally a fantasy created by mad physicists trying to figure out what the heck is going on when they do these little experiments. By little experiments, I mean big energy in little spaces and little pieces of time. It gets pretty nutty at that realm of things, and so subatomic physics was invented to try to figure that all out. We need a new science down there. It's called quantum physics, and it is subject to a whole range of debatable hypotheses, thoughts, feelings, intuitions as to what the heck is really going on.
So on the one hand, you had a theory which from the conceptual standpoint was profoundly puzzling, and on the other hand, from the practical standpoint, was vastly more successful than anything we had ever seen before. This is the kind of situation that produces the tension that all of the investigations of foundations of quantum mechanics are feeding off of since then. Because on the one hand, this is an acutely paradoxical, puzzling, conceptually confusing theory. On the other hand, we have no option along the lines of throwing it out or neglecting it, because it is the most powerful, proven tool for predicting the behaviors of physical systems that we have ever had in our hands.
The universe is very strange. There seem to be two sets of laws that govern the universe. In our everyday classical world, meaning at roughly our size and time scales, things are described by Newton's laws of motion, set down hundreds and hundreds of years ago. And they work very well for billiard balls and cannonballs and gravity. However, when we get down to a small scale, when we get down to, say, the level of atoms, a different set of laws take over. These are the quantum laws, quantum theory, quantum mechanics. And at that level, particles may be in multiple places at the same time. They may behave as waves smeared out spatially and temporally. They may be interconnected over great distances. They may be unified into one quantum state, into one state, governed by one wave function. And the borderline, the threshold, this curtain between the quantum world and the classical world is really mysterious. It's called sometimes the collapse of the wave function, because at the quantum world, everything is in superposition of multiple possibilities, And in the classical world, these multiple possibilities seem to collapse to particular definite choices. So everything is in one particular place.
When electrons move about the atomic nucleus, they do so in orbits. You have seen such models of the atom in high school books. You can easily recall them. But the subtle part comes when we think of how does the electron jump from one orbit to the other. A jump that is associated with the emission of light from atoms. Atoms emit light in the process. But how does the electron jump from one orbit to another? Niels Bohr was the first one to point this out, and it's radical. Electrons never go through the intermediate space, to the intervening space. Electrons never traverse any space in making this transition. They just are in the higher orbit, and then they are in the lower orbit. No space in between. So how does one make the jump? If you think in terms of continuity of movement, you can't find answers to that. So quantum fundamentally then means a discontinuity. This word quantum originally it just meant a quantity. In Latin it just means quantity. But that's not the way we use it in quantum physics. From the beginning, we used the word quantum in quantum physics to signify discreteness. And now signify a quantum leap, a discontinuous movement.
Quantum mechanics guarantees that the deeper you go, the more energetic nature becomes. It's for this reason that nuclear power is 1,000,000 times more powerful than chemical power. Why? Because chemical power represents a molecular manipulation. Nuclear power emerges from a nuclear manipulation, but the nucleus is 1,000,000 times smaller and 1,000,000 times more fundamental and 1,000,000 times more powerful than the chemical level. So the deeper you go, the smaller you go, quantum mechanics says, the more dynamic you become. The unified field exists at the ultimate scale of the Planck scale, 10 to the minus 33 centimeters.
The Planck scale is the very smallest level of reality. If we go down in scale, we're at meters, centimeters. If we go down to atoms, they're 10 to the minus 8 centimeters. Keep going down and down and down. Space-time is smooth until we get to the basement floor, the bottom level, where there's a pattern. There's a fabric, if you will. There's some kind of coarseness or irregularity. And that's at what's called the Planck scale, after Max Planck, the German physicist, at roughly 10 to the minus 33 centimeters. And the Planck time is 10 to the minus 43 seconds. So things are very, very small and happen very, very fast. Now, despite the fact that they're very, very small, space-time is everywhere, so the entire universe is created of this level. And Einstein's relativity says when this fabric curves up, it forms mass, and that's what matter is made of.